In this video, I want to have a look at cyclic quadrilaterals. But before we get into that, we need to know a few definitions. So concyclic points are points that lie on the circumference of a circle. So all these points here are called concyclic points because you can draw a circle that passes through all of them. Now, if we have any 3 points, as long as those 3 points don't lie in a straight line, then it's always possible to draw a circle that passes through all of them. But if we have more than 3 points, it's a little bit more complicated and it's not always going to be possible. So if it is possible to draw a circle through 4 points, then we say that those 4 points form a cyclic quadrilateral. So cyclic quadrilateral is a figure whose 4 vertices, so 4 corners, are concyclic points. So you can draw a circle that passes through all 4 of its vertices. So our first theorem involving cyclic quadrilaterals is that the opposite angles in a cyclic quadrilateral are supplementary. So if this one is x, then its opposite angle would be 180 minus x. And this one here, if it's y, this one is 180 minus y. Now the converse of that is also true. So if the opposite angles of a quadrilateral are supplementary, that means that the quadrilateral is a cyclic quadrilateral. Now if we have a look at an example of that, here we can see that our points A, B, C, and D are do form a cyclic quadrilateral. They're concyclic points. So if we move our quadrilateral around, we can see that no matter where we move it, our opposite angles are always going to be supplementary. So 104 plus 76 would give us 180, and 110 plus 70 would give us 180 as well. And that's going to hold no matter where we move them around that circumference. As long as they remain concyclic, they're always going to be supplementary. The other property about cyclic quadrilaterals is the exterior angle, so this one here that's marked as a theta, at the vertex of a cyclic quadrilateral is equal to the interior opposite angle. So we've taken our cyclic quadrilateral, we've extended one of the sides, and we've formed this angle theta here, and it's going to be equal to this angle up here. So if we have a look at what that looks like, here you can see this angle here is 114 degrees, and the interior opposite angle is also 114 degrees. Now if we move that around, you can see that they're always going to stay being the same size. So no matter how we move that around, it's always going to be equal to that opposite interior angle. So that's having a look at our 2 properties of cyclic quadrilaterals. Again, we will go through the proofs of those in class together.